So here's a problem, and I want to know if this series converges. And I'm looking at it and I'm seeing, well, this is an alternating series. I like to put the alternating part right in the front there between the summation sign and the B sub n. So it is an alternating series. This B sub n is equal to what? It's 1 over n factorial. Is this decreasing? Is B sub n plus 1 smaller than or equal to B sub n for all n? Is that true? Yes, that's true. If you're not sure, write out a few terms. When n is, well, is it for all n? It's for all n eventually, which is good enough. Because look, this one's starting at 0. What's 1 over 0 factorial? That's 1. When n is 1, that's 1 over 1 factorial. Well, that's true still. B sub the first term, or B sub when n is 1 is going to be smaller, is smaller than or equal to when n is 0. What's 1 over 2 factorial? 1/2. What is 1 over 3 factorial? 1 over 6. So yes, this is true, that I'm going to end up with this. 1/6 is smaller than or equal to 1/2. That's smaller than or equal to 1, and that's smaller than or equal to 1, and this is going to continue. So this is yes. And what about the limit as n approaches infinity of 1 over n factorial? That is 0. So it meets the two conditions. This series does converge. This series converges by what test? Alternating series test. Sometimes I'll abbreviate that AST. So then, if it converged, they want the sum to 3 decimal places. Well, let's write out a few of these. So I'll have the sum, as n starts at 0 and goes to infinity, -1 to the n, 1 over n factorial. 0, a -1 to the 0 is positive. So it's going to start off positive 1. 1 minus 1 plus 1/2 minus 1/6, then plus, let's see, we got 6 from 3 factorial. So the next one's going to be 4 factorial, would be plus what? 1 over 24? 4 factorial? 24. And then 5 factorial would be 120. 6 factorial, 720. 7 factorial, 5040. And I wrote them as fractions, but the key here might be to look at them as decimals. I'll do plus ... So, well, 1 minus 1, that gives me 0. I can just leave those off. So this would be 0.5 from the 1/2 minus, let's see what 1/6 is. 1 divided by 6 is 0.1 repeating 6. And then 1 divided by 24 is 0.041, repeating 6. 1 divided by 120 is 0.0083, repeating 3. 1 divided by 720, 0.0013, it looks like a repeating 8. Then 1 divided by 5,040, this is going to be a minus 0.000198,413. What's the next term, which would be 8 factorial? That would be 1 divided by 8 factorial, 0.00002802. And the thing about it, B sub n, since it's approaching 0, that absolute value of that is getting smaller and smaller and smaller. And if I want this to 3 decimal places, look at this term right here. I got 3 places right here, then a 0. This guy and anything after it is not going to affect the accuracy of my calculation at this point. And this one, well, this one might, but I don't think it will. It might. If this was 5 or bigger, that might. So what I need to do if I want to estimate the sum to 3 decimal places, I can just add those terms right there. Don't forget, I did have 1 minus 1 in the front. So if I include that 1 minus 1 plus all this, how many terms do I need? 1, 2, 3, 4, 5, 6, 7, about 8 terms. Okay? I know in the book they do it more formally than that, but 8 terms would get it for me. Some of the questions on WebAssign, they do ask, how many terms do you need?